Iterators are objects that let you iterate through the elements of a container, like a vector or string, and access their values. And just like pointers, where they point to a specific memory address, an iterator points to a specific element inside the container. And why we might use them? Some containers don't support using indexes. Like in this example, a vector supports indexing, and we can access the index either directly using the number or using a for loop with an I to access its indexes. And they are used everywhere, like in under the hood. For the range-based for loop, we can declare an iterator using the v.begin, where we have the v is a vector, and the begin marks the first element of that vector. And the end doesn't do the same thing. It's not the end, really. If we remove the bracket, the end points to an element after the last element, so it marks the end of the whole vector. So it doesn't point to the last element inside the vector. It points to an element after the last element, so it marks its end. And to go through the elements, we can just increment a certain iterator. So if I increment b, which is this one, it means that I'm going to the next element in the vector, which is this one. You can either use b or b plus 1, like b equals b plus 1, and that would tell the iterator that you want to go to the next element. And with the end, we can do the same, but by decrementing the end. So we can either use the e decrement, or we can decrement it by a certain number. So we can say e minus 2 to go to the element, this one. So it rewinds 2 places, so from 0 to 9 to 8. And you can use the auto, or you can use the std vector integer and then iterator to declare its type. But auto is cleaner and you don't have to worry about the type. And we can use it with strings. So we can use a string and we can mark its beginning and its end. And we can compare the beginning and end, where we can say if they are not equal. If they are not equal, we don't need to do this. We just have to dereference the cbegin, which is already the first character, and we can see that the first character was converted to uppercase. And in iterators, you can use a for loop. So you can declare an iterator for the beginning of the string, and you can compare it to see if it's not ended, you didn't reach the end. You can compare the iterator to its end, to the string end, and you can check if it's space, if it's white space. So if you dereference it, you will get what's inside the string. And then you can increment the iterator. By incrementing the iterator, you are going through the whole for loop as long as these conditions are met. And so what we do inside the for loop, we are just dereferencing the iterator and we are converting it to upper. So we are converting it to upper and we are assigning that result to the dereferenced string. As you can see in the debugger, we can see that we are first processing S, and now we are moving towards O. And now you can see that the O has been converted to an uppercase and the M, and you can see down the iterator is at E. So now it will process E and convert it to uppercase. And yeah, it will do this whole process until the string's finished. And until we reach the white space, it will stop, and you can see that all the characters behind the white space has been converted to uppercase. So why we are using the not equals to and not the like smaller sign? Because of vectors and strings, they support it, but other library types, they don't support smaller or greater than operators. So to play it safely, we just use the not equals to because of the iterators. But those are coming later, so I can't go through details because I didn't go through them. So it's a good habit. Just think of it as a better habit than using the smaller or the greater than operators. If you have a vector that holds string elements inside it and you want to declare an iterator, you can just copy the type just to make it fast to write, and then you use the iterator. So we are using the name iterator from the vector class, and if we just name that variable begin, and now we can use the vector of strings, and we can use the dot operator, and we can take the begin, which holds the object for the first element inside the vector. And if we want to work on that object, so if you want to use a built-in function for strings, you can take the begin and you you can use the arrow, and then you can check if the string is empty for the first element, like this element, if it's empty, if it's an empty string, so it doesn't hold inside it any characters. We can use an if statement, and we can see out something like string is empty. So we are basically checking if that string, the first element inside the vector, is empty, is an empty string. So now when we run the program, we can see that the string is empty, which is true. And if you want to work with the last element inside the vector, we can name the variable end, then we write equal, and then we use the dot operator to take the end. And we can decrement 1 to get actually the last one, because this one returns the object after the last element. And then we just say end and empty. If you want to check if it's not empty, we can add exclamation mark, and then we can write is not empty. And now we can see in the console log that the string is not empty. And you can use auto if you don't want to worry about the whole type of the iterator. And we can have an iterator for a string. It works the same way, it just points to elements inside the string, the characters inside the string, instead of a vector. And we can have a const iterator if we just want to read the values but not write anything. And for the string as well, we can also use a const iterator. To access the member of that object, we can also write it this way, where we open parentheses and we write here end, and we use the dot operator and we check if it's empty, which works the same way as the one before with the arrow. We are essentially dereferencing it and accessing its members. And to get a const iterator of the vector v, we can declare a variable, name it whatever we want, and we write the name of the vector, and then we use the dot operator and we use cbegin. And now we get back a const iterator for that vector. Or in the previous example, for the string iterator, we can get also a constant iterator by using the dot and cend. Just like normal for loops for an iterator, we just use the cbegin when we first declare the variable that we would iterate over. When we take the beginning of the vector, but we are using cbegin just to get the const iterator, and we check if it's not equal to the end and it's not empty, the vector is not empty, and we increment the iterator to go to the next element. And when we run it, it will print only some string because the first one is empty, so it's not going to print it. And this is how it looks in one line, so you don't find it confusing to see. It was formatted like this. And to calculate the midpoint of the vector, we can declare a variable, name it mid, and we can use the v.begin, and we increment it by the vector size, like v.size, and we divide it by 2. So now we have the midpoint of the vector, and to write a for loop that would stop at the midpoint. When we reach the midpoint, it will stop looping. We can create a variable, name it I, and then we can take the beginning again for the vector, and we check if the I is not equal to mid, and then we increment I. Inside it, we are just gonna see out, we dereference the iterator, and we end the line. So now we can see that the for loop ran only until the number 3, and the midpoint was 4. We can even see out the midpoint by just dereferencing it, mid, and end line. You can see that it is 4. It's the number 4 inside the vector. And we can use the equal or smaller than the midpoint to print the midpoint if we want. Like, you can use those operators as well. Now I'm going to use an iterator to write a binary search algorithm. First we have to declare the beginning and end for the string. So we use the s and dot operator and begin for the beginning. And then we can use a comma, and we can also initialize the end to s.end. And it should be sorted, so we are going to use std sort that would take the beginning and end of the iterator. It's going to take a beginning of type iterator and end of type iterator, which is the beginning and end of the string, this string right here. And to use it, we should include algorithm. And after sorting it, we have to calculate the midpoint index. So if I write midpoint index, the way we calculate it is by first adding a parenthesis, and we take the end and we decrement the beginning from it. And then afterwards we divide the result by 2 to get the midpoint index of the whole string, and to get the actual text, like the iterator, the mid-text iterator, we can declare a mid-text variable using auto, and then we increment the beginning with the midpoint index. So now we are telling the iterator to increment the beginning by, as an example, 2, or depending on what's the index that we are gonna get from this calculation. Then we have to declare a car variable to record what we are going to actually look for. So let's try m first, and now we have to declare a while loop. We can check first if the beginning has reached the end of the string. So if it didn't reach, we keep looping, and we add another condition to check if the mid text is not equal to the sort, so the one we are looking for, and we have to dereference it to get the car type, otherwise we'll get an error. And now let's say if the thing we are looking for, the character we are looking for, is bigger than the mid text, and we also have to dereference it, and we don't need the brackets. So if it's bigger, it means it's on the right side. So we have to change the beginning of it to the middle. And since we have already checked the mid text here inside the condition, the while loop condition, we can add it by 1, we can skip it. So we can add 1. So it means the iterator will also move 1 place after the middle of the text. Else, now if it's on the left, then we just say that the end is equal to the mid text. So we move back the end to the middle of the text. And then we just redo these calculations for the midpoint index. We reassign the value and redo the same calculation that we did before. And for the mid text as well, we do the same calculation again. Now to look at the debugger and see what the values are. So first you can see that the string has been sorted like this. That's the requirement for the binary search to work, is to have a sorted list or a sorted string. And we can see that the beginning is an empty string and the end is off the end, so it's a character outside after the t. It's the null terminator that we don't usually see, but it's there. And we can see that the midpoint index is number 5, which means it's, if we look at the mid text, it's the character n, and it's here. And what we are looking for is the m, so the one before the n, right before it. Okay, so the way the loop works is that it's first gonna check if the beginning is not equal to the end. So we didn't complete the loop. We didn't finish iterating over the string. And if the mid text is not equal to the sort, so the one we are looking for, we are using the mid text as a way to see if we found the sort, the one we are looking for, the character we are looking for. So as we can see here, we can see that the mid text is n, the character in the middle of the text is n, and the one we are looking for is the m. And m is right before n. So it's on the left side, so it means it's going to go into the else statement, and it's going to change the end to the middle. So the end now is going to be equal to the middle text iterator. So they both point to the character n inside the string. And now it's going to redo the calculation. We are going to recalculate the midpoint index, which means end minus beginning. The end was at n and the beginning, and what's the middle between them? The mid text, it's going to be g, the character g inside the string. And now we are going to check the condition if the beginning we didn't reach the end, and if g is not equal to m, which is correct, it's not equal. We are going to go inside the while loop and we are going to check if m is bigger than the mid text character, which is correct. M is greater than g. We are going to go inside the beginning and change it to the character in the middle plus 1. So mid text plus 1 is I, and as we can see, the beginning changed to I, and the midpoint index changed now to 1 after the recalculation, because end n minus I think m is going to be the mid text now. By 1 index, we are going to add 1 index to the beginning. So if we add 1 index to I, we are going towards m. So now the mid text is m, which is the one we are looking for. So it's not going to go inside the while loop anymore, and we are going to break out of it, and we found the character that we are looking for. This one is easier to read, but you can change how you calculate it by just removing this variable and doing it this way. So we remove this line if you prefer less lines, and you can try it yourself. You can rewrite it. You should rewrite it if you think you understood it. Try to rewrite it yourself to see if you have actually understood how it works. If I have this exercise that uses vectors, we have a vector with 11 elements, and each element has the default value, which is 0. And we are taking an input from the user, and then we are basically storing the count of each score between 0, 9, 9 and 19, 20 and 29, etc., depending on what the input is. So if we want to convert it into an iterator, how would we do it? It is currently using the indexes to increment the count of each score. Since we are calculating the index, where if the user, as an example, entered 100, we are going to divide it by 10, which becomes 10. So it becomes the index 10. So instead of using the indexes to access it, I can take the beginning. I can store here, I can store the beginning of the scores vector. So I can take scores.begin. And then since I'm calculating the index right here, I already have everything. I just need to do something really small. So I can declare a new variable, or I can use the beginning. I'm gonna do it this way right now. I'm gonna declare a variable that would point to the score that we are gonna increment. So let's name it current score, and let's say it's beginning plus index. So now we have an iterator for the current score, and now we just can increment that current score by 1, which means it would increment the count of that score in the vector by 1. So if I run the program, let's enter 10 and then 200 to break the program, and now we can see that 10 to 19 has been incremented. Let's try it again, 20, 21, 22, and then 200 to break out of the loop. We can see that 20 to 29 scores has been incremented by 3, which is correct. And this is how we can use iterators instead of indexes to count the number of grades by each grade group using iterators. In this function we have a vector of strings. It's named text, and inside it we have 3 strings. One of them is a blank string, and we have a for loop that would print the first paragraph until it hit a blank line or a blank string. It will stop looping using the empty method for strings. So it has 2 conditions where we check if it didn't loop through all the vector and it didn't find an empty blank string in the vector. So when we print it, we are gonna see only the first paragraph, which is some string. And we have an assignment to revise the loop that printed the first paragraph in text to instead change the elements in text that correspond to the first paragraph to all uppercase. So we need to make this string to all uppercase, and after that we have to print the contents. So in order to convert characters to uppercase using the string itself that we are looping over, when we want to convert a character to uppercase, we just use toUpper. That would take a character, but since when we dereference we are getting a whole string, we aren't getting a character. So we need to create another loop inside the for loop. So if we create a for range based loop, we can dereference the iterator, which gets us the string. So now we can access each character inside the string, and we can say that character equals toUpper and then character. And if we see out the character that we have just updated to uppercase, we can see that it has changed inside the for loop but not outside. What that means, it has created a copy of the characters, but it didn't change anything inside the vector. So in order to change actually what's inside the vector, we should have a reference, but then we would get an error because we are working with const, and if you remember, in constants we can't change the values inside them. So we need to remove the const. We just work with the end and beginning. And now we need to delete the C out. And now we can see that it has worked correctly right now. And all characters has been converted to an uppercase letters. And here we need to cast it to character to remove the warning, but it would work anyway. But this way is better. And if we use a range-based for loop to print everything inside the text, we can do it. And here we can see that it printed it correctly. It printed the uppercase and the blank string and another string, which is inside the vector. What if someone who's really annoying told you to do it using iterators instead of a range-based for loop? Let's create a normal for loop and let's access each character inside the string, and we do it by using it, the string inside the vector, and then we should use the arrow because it's a pointer and we point it to the beginning. So now we have the first character, and we check if C is not equal to the end, does not point to the end of the string, to use it and then arrow end. We increment and we open brackets and we dereference C and we make it equal to, let's just copy the same line again to save time, dereference C again, and let's run the program and we can see that it to uppercase. And if we look at the debugger, we can see how it's working. C is now at O and it has converted S to uppercase. It has done that to O. Next is M, next is E, and that's how it's working.